So in this video, I just want to show you a few additional application problems that might be helpful. The first one we touched upon in class with the Pythagorean theorem. A right triangle has a right angle in it, 90°, which is what we call the right angle. The hypotenuse is this diagonal line that connects the two legs, and we talked about these being the legs that form the right angle. So the Pythagorean theorem is a squared plus b squared equals c squared. If this is leg A and this is leg B and the hypotenuse is c. So you might see a story about this is a cell phone tower and a wire is attached to it for support. The length of the wire is 40 meters less than twice the height of the tower. Now they actually give you in this problem, they give you these pieces that we have set up in class. But you might be expected to read this and determine that I don't know the height, so I will give that a variable x. The wire is attached out here, so the length of this wire, it says, is 40 meters less than twice the height. So if the height is x, this would be 40 meters less than twice the height. And it says it's fixed to the ground at a distance 40 meters more than the height. So you would have to understand that you had 40 to x, which was the height. Now it wants you to find the length of the wire. So using the Pythagorean theorem, a squared plus b squared equals c squared, we're going to take x squared, which would be my a, and I'm going to add b squared, and that will equal c squared. And now we have to solve this equation. So we say, well, the first thing we want to do is set it equal to 0. So we can subtract all this from this side. Setting it equal to 0. Or you could have FOILed this first, multiplied all this out, and then subtracted this. So x squared plus, be careful, this is not x squared plus 40 squared. It's a whole FOILing process. X squared, and then you'd have 80x plus 1600 minus, and then we have to FOIL the remaining, this polynomial, so that would be 4x squared minus 160x plus 1600. Now I took a shortcut and I just knew what the FOILing of this would be, but you would take it and write it out and FOIL first, outer, inner, last, or put it in your box and multiply it out. And that equals 0. So this negative sign gets distributed into all of these things. I can combine those, 2x squared plus 80x plus 1600 minus 4x squared plus 160x minus 1600 equals 0. 1600s cancel. X squared minus 4x squared is negative 2x. $80x plus 160x is 240x equals 0. To solve this, I'm going to factor out a GCF. I'm going to factor a negative 2x out, leaving x minus 120. So this is my zero product property. Either this is 0 or this is 0. So x is 0 or x is 120. We discussed the logic. X represents the length or the height of the cell tower. It can't be 0, so it has to be 120. This is the other application I thought I would go over. It's very similar to what we did in class, where they give you the equation. So you don't have to come up with your own equation, but it's very important that you interpret everything correctly. So it reads that we're talking about household incomes under 100,000, and it's relating the percentage of households with home broadband access. So in other words, they're seeing how many people with incomes under $100,000 have internet. And it's comparing that to their household income, which is modeled by this. So if you know a value for X, you can plug it in and get Y. And they're telling you X is the income in thousands. So if you had a $50,000 income, X would be 50. If you put that in there, you would get Y, which is the percentage of households with internet. So it wants us to use this model to estimate the annual household income. So it wants us to get the annual household income. X is the household income, so they want us to be solving for X. And they give us the percent, and Y was the percent. So it's just really important that you know, are they giving me this variable or are they giving me this variable? And you have to be very careful to plug it into the right spot. So we're going to estimate or compute the income when they give us the percent, which is Y. So they give us 75.5, and we're going to plug that into our equation. We always want to set equal to 0, so we'll subtract 75.5 from both sides. 9.5 minus 75.5 is negative 66. Now we have decimals in here that we don't like. I could try to divide everything by 0.01, or I could multiply everything by 100. So let's do that. We'll multiply everything by 100. This term, this term, this term, this term. All straight across the board, everything gets multiplied by 100. So 0 times 100 is 0. That will move this decimal out 2 places. So I have negative x squared. It'll move that decimal out 2 places, 170x, and it'll move that decimal out 2 places, giving 6,600. Now I don't like this negative in front of this x squared, so I'm going to factor a negative symbol out of everything. So now I have a quadratic equation I can solve. I can either try to factor this, or I could try to use the quadratic equation. I like to try to factor first, but it's your option which method you use. This is factorable, x minus 60 and x minus 110. So that gives me a solution of x equals 60 or x equals 110. So this is nice because in neither of these situations do I have a negative number, and we're saying that x represents the annual household income in thousands. So it would either be 60,000 or 110,000. So neither of those is negative, so I don't have to throw either of those out. But if you pay attention to the story, it says household incomes under $100,000. That is not under $100,000. So we throw that out, not because it's negative or for any other reason other than the fact that it says it has to be under $100,000. So my answer would have to be 60,000 or 60.